Students, once again I welcome you back in the session of physics classes for class 9. We have already discussed 4 parts of chapter 1. Today we are going to discuss part 4 of physics class 9, that is measurement of time. We all know that there are 3 basic quantities: length, mass and time. We have studied about length and now we will study about the measurement of time. We all use clocks for measurement of time or for noting of time in schools, colleges, homes and offices. Therefore, it becomes a very necessary part to be studied. So, in homes, schools, colleges and offices, we use pendulum clock mostly for measurement of time. This clock, that is pendulum clock, is based on the principle of oscillations of pendulum. It is based on principle of oscillations of pendulum. This is the principle behind pendulum clocks. So, here the question arises that what is pendulum? Is it? You might be thinking. In class 8 also we have studied something about pendulum. But in class 9 we are going to discuss it in much more detail. So let us study about what is pendulum. Pendulum is oftenly known as simple pendulum. What is simple pendulum? A simple pendulum is a heavy point mass which is suspended from a rigid support. Let me draw a diagram, then I think it will become more clear to you all. So let us see about pendulum. So this is the rigid support. And here we are tying a heavy point mass. This point mass is known as bob. B-O-B. It is known as bob. And this is known as string. Okay. So, a simple pendulum is a heavy point mass which is suspended from a rigid support by an inextensible string. So this is the diagram for simple pendulum. This is the rigid support and this is the bob. Okay. So when we are applying force on this bob, when force is applied on this bob, what will happen? It will start moving from its initial position to final position like this. You all might have seen pendulum clocks at your home or in offices. So, if force is applied, then how it will move? It will move like this. It will move from here to here, from here to here and back to. This is position A, this is position B and this is position C. A position is known as mean position and B and C are known as extreme positions. Beyond this point, this bob cannot go. And this is known as the string. The total length is taken from point here to this point. It is O. This total is known as the length of the string, which is denoted by symbol L. Small l we are using for denoting the length of the string. So whenever force is applied, this A will be moving to B, B will be moving to C, and like this, the pendulum will move. So this was about simple pendulum. Now, what are the terms that are related to pendulum? This we have to study in detail. Terms related to pendulum. We have to study what are the terms which are related to pendulum. First one is oscillation. Just now I was telling you what is oscillation. One complete to and fro motion. This is known as to and fro motion. We have studied in class 6 and 7. So one complete to and fro motion is known as one pendulum. Here it will be from A to B, B to A to B, B to C, and then back to A. From A to B, B to C, and then from C to A. This will be known as one complete oscillation. Second term is time period. Time period is denoted by symbol capital T and its SI unit is seconds. Is it? How we will be defining time period? Time taken to complete one oscillation. This we have studied that starting from A and coming back to A is one oscillation. So whatever the time is taken to complete one to and fro motion, that will be known as time period. And it is noted by symbol capital T, SI units is seconds. Third one is frequency. Frequency is noted by symbol small f or small l. SI unit is second inverse, or it is also known as hertz, which is noted by symbol capital H, small z. So, what is frequency? Number of oscillations made in 1 second. In 1 second, whatever the oscillations are made, 1, 2, 3, 4, 1.5, 2.6, whatever it is, whatever the number of oscillations are made in 1 second, that is known as frequency. So, number of oscillations made in 1 second, that is known as frequency. Now, another thing is relation between time period and frequency. One of the most frequently asked question in exams. Relation between time period is noted by capital T, and frequency, that is small f. So what is the relation between time period and frequency? Time period is equals to 1 upon frequency. Or we can say frequency is equals to 1 upon time. So this is the relation between time period and frequency. Next term is amplitude. Fourth term is amplitude. Amplitude is denoted by symbol capital A and its SI unit is meter, because it is a type of distance and distances and length are measured in meters. So what is amplitude? Maximum displacement on either side. You can see this is the maximum displacement. This, the distance AB or the distance AC. Here AB will always be equal to AC. This distance will be same. So amplitude is the maximum displacement on either side of the ball. That is known as amplitude. and it is noted by capital A also and small a also. This is amplitude. Next term is effective length of pendulum. Effective length, or it is also known as length of the pendulum. So I have already told you, distance from the point of suspension from the point of oscillation. This distance, that is from O to A, is known as length of the pendulum. Distance from point of oscillation to point of suspension. Distance from point of oscillation to point of suspension. That is, in the figure we can say OA. This is known as the length of the pendulum, already denoted. And it is noted by symbol small l. Okay? Next is for time period of pendulum. One note point you should write. We have discussed about the least counts of screw gauge, of vernier calipers and meter rule. In the same way, least count of stopwatches or watches may be 1 second or 0.5 seconds. It may be 1 second and 0.5 seconds depending on the number of divisions. Further topic is that if we have to find time period of the simple pendulum, what we have to find out? If we have to find time period, if we have to find out time period of simple pendulum, then we will be using the relation T equals to 2 pi under root L by G. T equals to time period, L equals to length of the pendulum, this small l, and G equals to acceleration due to gravity. Pi is itself a constant number whose value is 22/7 or 3.14. So whenever we have to find out time period in numerical values or in numericals, we will be using the formula T equals to 2 pi under root L by G, where T equals to time period, pi equals to 3.14, L equals to length of the pendulum, and G equals to acceleration due to gravity. At any given place or at a given place on the surface of Earth, the value of G, that is acceleration due to gravity, is constant, and its value is 9.8 meter per second square. And if value of gravity is fixed, then time period is also constant. If value of gravity is fixed, then time period is also constant for a particular length. At any given place, if value of G is constant, we all know that it is 9.8 meter per second square. So time period will also be constant for a given length or for a particular length, we can say. And it is because of this value, it is because of this reason that pendulums can be used for the measurement of time, because its value is remaining fixed. Now, further moving into the chapter, we have to study that what are the factors which are affecting time period and what are the factors which are not affecting the time period. So, we will be seeing the formula. First of all, we are discussing factors affecting the time period of simple pendulum. For finding out what are the factors affecting any of the quantity, we should see the formula. T equals to 2 pi under root L by G. We know that first factor which is affecting is length of the pendulum. So the first factor which is affecting the time period is length of the pendulum, or we can say the effective length of the pendulum. How? P is directly proportional to square root of length. Second factor is acceleration due to gravity. So what is it? T time period is inversely proportional to square root of gravity. These were the factors affecting the time period. Now, factors not affecting the time period. What are the factors which are not affecting the time period? Mass, material of the bob, whatever it is made up of, mass of the bob, we can say material of bob, whatever the material the bob is made up of, it will not be affecting the time period. And second thing is the amplitude of the bob. Amplitude, this distance will also be not affecting the time period. And the last topic of chapter 1 is second pendulum. Up till now, we were discussing and talking about simple pendulum. But there is one more pendulum that is known as second pendulum. So what is second pendulum? This is the pendulum which all of us use in our homes for measuring of time, or we can say for noting of time. We are using this pendulum that is known as second pendulum in a home. So how we are finding out? It takes, see, this is the mean position. So it is taking 1 second to go from, see, from one extreme position to mean position. Or in simple words, you can just say from going from A to B, it is taking 0.5 seconds. Again from B to A, it is taking 0.5 seconds. From A to C, it is taking 0.5 seconds. And again from C to A, it is taking 0.5. So 0.5 into 4 equals to, what will be equals to? 2 seconds. So this is the pendulum which we are using in our home for noting of time. It takes 1 second to move from one extreme position to another. From here to here, one extreme position is B, another extreme position is C. So from B to C, it is taking 1 second. Then from C to, because it has to cover this distance also, it will be starting from A to B, and from C to A, it will come back. So 0.5 from A to B, 0.5 from B to A, 0.5 from A to C, and so it will be taking 1 second from B to C and half second from here to here. Total, we can say that the time period of second pendulum will be equal to 2 seconds. So the pendulum which is having time period of 2 seconds is known as second pendulum. This was all about the chapter 1, that is measurement and experimentation. So students, note all the things in your copies. Just see the examples, read the chapter and prepare your notes and study further. Have a nice day.